kept a working machine, John? Why?
How can he keep it if people take him from him?
Right.
Well, trouble is, when people see, gosh, we've got millions of dollars here,
Yeah.
we could take it and own it.
Mm-hmm.
And they either steal everything, your equipment, to stop you working, so you can't do nothing.
Mm-hmm.
They then think you'll get on your hands and beg them, you give them the secrets needed to make that magnetic setup right. Of course, I don't submit.
So it's,
to
yeah.
The
people.
last unit was back in '82.
Right.
And
The last one that was
right.
over Unity.
He had it between the walls. It was powering his home. Eventually, the Midlands Electric, was it Midlands Electric Company?
Midlands Electric,
Yeah,
yeah.
they noticed he didn't have a bill, and yet he had electrical power, and
Right.
that's when he had a lot of problems.
Right.
Because at one point I'd like to push here is that people will say, well, if you made it in 1946, why can't you do it now?
Mm.
But in 1946, the bag of SG was £108 for me. I'd like to see somebody go and make an SEG today for that money. It costs millions to make one off.
Right.
The next thing is that those types were made just for our own pleasure. It took 3 months to make each one. Production, that's useless. You can't do that. So I had to rethink how we could turn that into a production model. This is what Morris is working on. The suggestions have been put to him, and he's working on it. And so far, it's green. Gone green. It's okay. I'm satisfied. Everything's looking good for a production machine that can be mass produced. If all goes well, and there's no problem, the first unit, we can up and down the part and it makes no more function. I can say, right, we can go on to the production line now with it. Now, with this thing is, it's a new technology. We have now changed from the old system to another system which is fast and quick to mass produce. At SEG, you need at least produce a couple of thousand a week on the line, or it's no good from the point of economics. So it's a matter of producing a system that you just can bang them out. And at the moment, that looks very good. At the moment, I'm quite happy how things are going. But the cost today to do it is terrifically. And every year the price is going up. And we can't control the price. It's the market that's controlling the price. So the sooner we get this going, the cheaper the units will be. And the more lines we get running, the cheaper still, because when you buy more and more bulk, the price goes down.
Okay.
So these are issues people don't think about.
Some people wonder why you haven't applied for a patent for this device.
But
Can you
the
explain?
big thing is that we're trying to get something we can mass produce, that produce the energy as the original machines did. And secondly, it's while we're struggling to get this, you've been stopped time and time again by people who want to own it. They should just steal your property, so you can't move. You got to start again.
I know if we try to patent the U.S., you know, they always screen these patents.
Oh, no, I'm aware of that.
It rings bells. Says this
Yeah.
could be a weapon and all that, and
Yeah.
then they can immediately stop you.
Right, yeah.
So we rather copyright it or just keep it in house. In fact, the magnetization process, we're not going to patent it. It'll just be a company secret.
Right. And Fernando, have you looked at any other over Unity devices, like for example the Stan Meyer cell or Pons and Fleischmann? Because I'm actually looking at those now and studying them, and I believe there's credence.
I really don't know much about those other ones. I'm focused on John's technology.
And is there anywhere where people can get updates on your progress?
Certainly. Well, we have a website called searlsolution.com.
Searlsolution.com. Okay.
SEARL solution.com.
And you know, if you do get over Unity, you know, what would the next stage be then?
Well, we have to be careful. We have to make sure it is fully developed to the extent that we can present it.
Right.
One of the most dangerous positions we could be in is just having one demonstration unit.
Right.
We'd rather have
Yeah.
a lot of them,
Yeah.
just to make sure that there are no incidents.
And let's say you've got your demonstration unit that demonstrates over Unity. you then need to prove it in a university somewhere.
I wouldn't call it over unity. It's a unit that's converting energy,
Right.
and which is why you have this temperature drop.
Right. So the actual source of the energy for the electric current comes from the surrounding temperature of the room.
It's ambient, right. So your room temperature will drop. That's the only consequence of it.
Right. So would this not, let's say you were using it to power something quite big, you know, like, I don't know, a big machine, would it not completely freeze, you know, would the temperature drop not be just vast, so it would cause problems with, do you know what I mean? Or does it not work like that? I mean,
you just work it outdoors, but
right.
it is scalable. The smallest unit we can make is 15 kilowatts using John's way of designing it. And that's the beauty of SEG. Is simply the more massive, the more power you get out of it.
Right.
And
so if you're powering your house off it, let's say, I don't know, let's say 5 kilowatts, something like that, there'll be no problem with it. Making your house really cold or something.
Well, we should ask him. He had one for 31 years operating his home.
No.
So did you convert it to 240 volts, John?
Yeah, the power was for 240 with 50 cycles raised to give us 50 cycles. So bear in mind that when you're not drawing power, it has an idle speed.
Right.
It keeps running, never stops.
A bit like a turbine generator in a power station.
Just idle. It means it's fully charged. As soon as you switch on, the flow starts and the rollers speed up.
As you add load onto it. That's just phenomenal. So it's got its own built-in governor then, that's what you're saying.
It immediately reacts because, think about what you're doing. You're drawing more current out of it. Consequently, it drives the rollers to move faster.
Yeah. You must bear in mind, it's a linear motor on a magnetic bearing. But also a diode is one direction. Secondly, it's an auto transformer. And again, the input in this machine is coming from all the fabric around itself. It is putting it in uniform motion. It is now pushed out on the outer copper or aluminium, whatever material you pick, goes onto the back of the roller.
Right.
Now the back of the roller, due to rotation, is short and it's longer on the front. Newton's law is clearly seen. The electrons coming back of the roller gets to the top very quick. It's accelerating. Right. Now, it can't turn to go around it, because to do that, as Newton said, you've got to apply a force. So they just come off to the next ring, which is waiting to receive any energy around itself. And the process keeps on till you get to the final rollers of the third set. This then jump to the coils or a brush, depending what system you're using. Then conventional concepts come into play. In other words, you've got very high voltage, so you drop it to the voltage that you want. This gives you, well, current's proportional to the voltage, so you get your